So today we get to start row operations. Now, what row operations are is a form of modifying a matrix in order to do some sort of specific task. This is the first thing that isn't what we consider a fundamental principle, but it's a pretty basic principle, which is why it's in these first few videos that we normally cover on matrices. So all a row operation is when we label what we've done from one row using a combination of other rows. So if I say I'm going to take row 2 and I'm going to replace it with row 1 plus row 2, I rewrite the matrix by saying, let's go ahead and zoom in here. I'm going to take row 2, so I'm going to take 3, 4, and 5, and I'm going to replace it with 1 plus 2. So 1 plus 3 goes in for row 2, 2 plus 4 goes in for row 2, 5 plus 7 goes in for row 2, which when simplified will give me a 4, a 6, and a 12. I did not touch row 1. Row 1 is not changed. I did change row 2. If I say row 2 is multiplied by half, I take what was row 2, and I say 4, 6, and 12, half, half, and half is going to give me a 2, 3, and 6. And you can even do much more complicated versions. You don't need to do it one at a time. I could multiply a row by something and add it. So I could say, okay, how about I take row 2 and I replace it, this bottom one, with a negative 2 times row 1 plus row 2. So I could say 2 is going to be replaced with negative 2 times 1 plus 2. Negative 2 times 2 plus 3. Negative 2 times 5 plus 6, which when simplified will give me a 0, negative 1, and negative 4. Now, let's go ahead and try those same operations on this example. I'm going to be replacing row 2, which means I leave row 1 untouched. So I'm going to give myself a nice bit of room here. Throw my augmented line in there. And I'm going to say row 1 is untouched. So 1, 4, 3. Now what I am doing is I'm replacing row 2 with row 1 plus row 2. So 1 plus 5. 1 plus 5. 4 plus 8. 3 plus 9. So what I get now is my new matrix is 1, 4, 3. Throw my augment line in there. I'll get 6, 12, 12. If I keep following the same set of examples, I'm going to replace row 2 with half of itself, which again means that I'm going to leave row 1 untouched. 1, 4, 3. And I'm going to replace row 2 with half of itself. So half of 6, half of 12, and half of 12. Which means that top row untouched, 1, 4, 3. My augment line in there. Half of 6 is 3, 6, 6. The fun one right here is I'm going to replace row 2 yet again. Now, just as a disclaimer, there's nothing against doing anything to row 1. I just happen to give you 3 sets of instructions which simply related to row 2. So row 1 untouched. 1, 4, 3. Row 2 will be replaced with negative 2 times row 1. So negative 2 times 1 plus row 2. So plus 3. Negative 2 times 4 plus 6. Negative 2 times 3 plus 6. Oh. So if I simplify that, I get this matrix of, let's see, we didn't touch the top, so 1, 4, 3. Augment line is tossed in there. I'll get, let's see, negative 2 times 1 is negative 2 plus 3 is 1. That's a negative 8 plus 6 is negative 2. That's a negative 6 plus 6 is 0. And so that's really all row operations are. You can see that we just replace the row that we state with whatever we've done to either the row itself or other rows. Now, we're really not going to see too much with this until a later section, but the standard function is we don't ever do anything to a row that simply involves other rows. What you've noticed is that row 2 did involve other rows, but it always includes part of row 2. it always includes part of row 2 in its functions. So even though I'm throwing row 1 in the mix, I'm not here and I am here. Row 2 always consists of at least part of what it was. We're modifying the rows, we're not just rewriting them. So starting off here on the bottom is we're going to identify what row operations have occurred and label the changes in standard form. So we're going to label the changes according to what we saw earlier. So let's take a look. So it looks like row 1 was a 1 and a 2, now it's a 4 and a 6. So I could say it is a 1 plus 3, 2 plus, nope, that would be a plus 4, so I can't add something. But I know that row 1 has something that's happening to it. Looks like row 2, nothing's going on. So I can basically ignore row 2. You don't actually need to cross it out, but I'm not looking at this. This doesn't exist to me. I'm only looking at 1 and 2 turning into 4 and 6. So if I can't add something consistently, how about I just see, okay, 1 times what gives me 4? 2 times what gives me 6? Well, 1 times 4, 2 times 3. So it's not simply a multiplication. I could look at, well, how about this? 1 plus 3 is 4, 2 plus 4 is 6. So it's a combination of row 1 plus row 2. There we go. And so again, let's take a look right here. I notice that my row 2 isn't touched. So that means that I'm simply going to be looking at, there's a change in row 1. So what do we do to row 1? And so pause the video, see if you can't figure out what's happening here, and write down the rule. Now you may get more than one rule, that's okay, but write a standard rule for what we did to get from 5 and 6 to 10 and 12. Yeah, okay. So you might have been looking at the 7 and 8 and saying, well, that would be a 12, no. That would be a 14, no. I could divide. The second row really is going to help right here, but I do notice that 10 is double 5 and 12 is double 6. So it's probably going to be row 1 doubled. And there we go. And the last one of the hardest ones, what we're seeing here is that we're seeing a couple different things. I notice row 1 changed. So I'm going to write a rule for row 1. Row 2 changed. I'm going to write a rule for row 2. And row 3 changed. So I'm going to have to write a rule for that. So a couple different things I could do. Now I could try and come up with a rule for 4, 5, 6. I could also notice that 4, 5, and 6 were swapped. So you're going to have multiple options here which are correct. You could say, okay, row 1 is now what was in row 2, and that would be a correct answer. One of the things that we did mention is that when we swap rows like this, I could write this in terms of the original line. So I could say, actually, row 1 is made up of row 1 plus 3. And that would actually be a correct answer as well. I could say row 2 is going to be the old row 1, and that would be a correct answer. Or I could say that row 2 is going to be row 2 minus 3, and that would also be a correct answer. And so you'll see that the rules that we're spotting here when we're trying to do this type of exercise can be very varied. You can even go so far as, how about I just say row 1 and row 2 are swapped and draw an arrow going both ways. And we'll actually use this trick a lot because what we're doing is we're not rewriting the matrix, we're just reorganizing rows, which is allowed. Rewriting columns isn't necessarily done as much, but it can be done as well. So what do you think you came up with for row 3? Well, it looks like with this one, row 3 is, let's see, double, 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 and we change the signs, so it's going to be -2 times row 3. And there's actually, again, when you're trying to spot rules in this type of exercise, the answers really are endless. But that is good practice for our next set of problems. Now, this is telling us to do row operations. So the first thing we spot is we see that little swip swap, which means we're going to swap the rows. So let's go ahead and give some of these a try as opposed to figuring out what's going on. Let's just do some of them. So this matrix, I'm going to take row 3 and swap it with row 1. What I know is that by swapping row 3 and row 1, row 2, 4, 4, 6 isn't changed. So I'm just going to copy that one down. The only changes happen here and here. So I'm going to move my 1, negative 2, 0 up top. I'm going to move my 2, 0, negative 3 down bottom. Cool. And these are going to be consecutive actions, so I'm going to take this matrix and move it over. Okay. So what I'm going to do is I'm replacing row 2, which means row 1 and row 3. 1, negative 2, 0, 2, 0, negative 3 remain unchanged. The only row I'm changing is row 2, this middle row. So I'm going to take row 2 minus 4 of row 1. So 4 minus 4 of these. 4 minus 4 is 0. 4 minus 4 of these, so minus 4 of these is going to be plus 8. 4 plus 8 is 12. 6 minus 4 of those is just going to be 6. Awesome. And so the next thing I'm going to do, again, I'm only modifying row 2 here. So I'm going to keep row 1. I'm going to keep row 3. And I'm only going to modify row 2. And I'm going to take row 2 and I'm going to make it 1/12 of itself. So a 12th of 0 is 0. A 12th of 12 is 1. And a 12th of 6 is 1/2. Awesome. The last part is going to be I'm only modifying row 3. So what I'm going to do is I'm going to keep my matrix right here and copy down row 1 because I'm not changing it. Copy down row 2 because I'm not changing it. I'm only going to modify row 3, which means that I'm going to say, okay, row 3 minus 2 of row 1. So 2 minus 2 of these, 2 minus 2 is going to give me a 0. 0 minus 2 of these, well, that's going to be plus 4 is 4. Negative 3 minus 2 of those is going to be nothing, so negative 3. Awesome. And then now the way this is set up is I've set it up so that you can take your answer right here and check the next piece and say, hey, from here to here, are these the same thing? 1, negative 2, 0, 0, 1/2, 0, 4, negative 3. Yes, we did these row operations correct. Because the thing is, if we make a mistake right here, our answer is going to be carried off, and they're very difficult to find things. So I've tried to build the sheet so that you can check along the way. However, we will be stopping here and resetting. So let's see what happens when we get all the way to this number D. So why don't you go ahead, and now that you've seen one full set, try out number 2, work through all the way to D, and stop here and look at your answer and see if there's anything special about your answer. Unpause the video when you're done and see all you did. Okay. So let's take a look at what's going on. So if I take this and I'm replacing row 3, I'm going to go ahead and I'm going to copy down row 1 and 2. 1, negative 2, 0, 0, 1, 1/2. I'm going to take row 3 and subtract 4 the thing above it. 0 minus 4 zeros, 4 minus 4 ones, negative 3 minus 4 halves. 4 halves is 2, so negative 3 minus 2 is negative 5. My next step, again, I'm only modifying row 3, which means copy down my top 2 rows and take that third row and multiply itself by negative 1/5. Negative 1/5 of 0, negative 1/5 of 0, negative 1/5 of 5 is 1. From next one, I'm only modifying row 2. So I'm going to go ahead and I'm going to leave everything else. 1, negative 2, 0, 0, 0, 1. And I'm going to take row 2, take itself, and subtract half of the thing below it. So 0 minus half of 0, 1 minus half of 0, half minus half of 1, so half minus a half is 0. Okay. And then my last step is I'm only modifying row 1. So I'm going to copy down 0, 1, 0, 0, 0, 1. Let's see what we get. So row 1 is going to take itself and add it to 2 of row 2. So take itself and add 2 zeros. So 1 plus 2 zeros is 1. Negative 2 plus 2 1s, so that's plus 2, is 0. And 0 plus 2 zeros is 0. And so what I've got right here looks rather special. I've got a series of zeros with a diagonal line of 1s. And so what do we call that? Well, if you're familiar with this, this is what we call the identity matrix. And this is going to be something that's very special that we're going to cover in a later section. So just go ahead and, if you wanted to, sketch down this is the identity matrix. Which is a matrix filled with zeros with a diagonal line of 1s. Awesome. So just to make sure we got the idea, that was a good example with a 3 by 3 matrix. We're going to take a quick look at number 5 and number 6. We're only going to do half this. We're not going to go all the way through. Try a couple of these row operations. Go ahead and pause the video, unpause it when you're done, and see how well you do. Okay, so what we've got going on right here is the identity matrix, or not the identity matrix, this matrix right here, we're going to modify row 2. So I'm going to copy down everything else. Row 1, row 3, and row 4. And I'm only going to modify row 2. Take row 2, add 4 of the thing above it. So negative 4 plus 4 of these is going to be 0. Negative 59 fifths plus 4 of those is going to be adding 12. So what we're going to do is we're going to pop down a scratch sheet of paper to make sure we're doing this right. So I'm going to take row 2, which is negative 59 fifths, and I'm going to add 4 of the thing above it, so plus 12. 12, I'm going to have to recombine that into fifths, so negative 59 fifths. 12 times 5 is 60 fifths. Oh, that's not nearly bad. That's 1/5. So I get that. And then I'm going to keep going. I'm going to say, okay, row 2 plus 4 of the thing above it. So row 2 is 8 plus 4 of those. Well, 8 minus 8 is 0. Plus 4 of those, that's minus 4 is going to be 1. Awesome. If I move on to the next step, I see I'm only modifying row 2, so I'm going to copy down everything else. So 1, 3, negative 2, negative 1, 0, negative 2, 1/2, negative 9, negative 2, negative 6, 6, and 9. I'm going to take row 2 and multiply it by 5. So 0 times 5 is going to be 0, times 5 is 1, times 5 is 0, times 5 is 5. Awesome. And then right here, I'm only going to modify row 3. So I'm going to take row 1, 2, and 4. 1, 3, negative 2, negative 1, 0, 1, 0, 5, negative 2, negative 6, 6, and 9, and I'm going to keep them right there. And I'm going to go look at row 3. So I'm going to take row 3, which is this row, and I'm going to add 2 of the thing above it. So if you're having trouble keeping track of this, again, I would encourage just sketching out a little thing to the side. So 0 plus 2 zeros is going to be 0. Negative 2 plus 2 1s is plus 2. 0. Half plus 2 zeros is half. Negative 9 plus 2 of these, well, 2 of these is 10. Negative 9 plus 10 is 1. Awesome. And so let's take our answer and compare it. Let's see. 1, 3, negative 2, negative 1, 0, 1, 0, 5, 0, 0, half 1, negative 2, negative 6, 6, 9. Yep, we perform those row operations correctly. And so number 6, after we've hit that checkpoint, we're going to go ahead and kind of continue our way onwards. I'm going to keep my scratch paper off here to the side just in case I need it. And I'm modifying row 3, so I'm going to copy down all the other rows. 1, 3, negative 2, negative 1, 0, 1, 0, 5, negative 2, negative 6, 6, 9. Row 3, I'm just going to double it. 0, 0, 1, 2. Moving on. I'm going to modify row 4 this time. So I'm going to copy down rows 1, rows 2, and rows 3. Row 4 is going to be itself plus 2 of the top row. So negative 2 plus 2 of these, so that's plus 2, plus 2 of these, 0, plus 2 of these, so that's 6 minus 4 is 2, plus 2 of these, that is 7. Awesome. Modifying row 4 again. So what I'm going to do, copy down everything in rows 1, 2, and 3. And I'm only going to modify row 4. I'm going to take row 4 and subtract 2 of the thing above it. So minus 2 zeros, minus 2 zeros, minus 2 ones, and minus 2 twos, which is minus 4, gives you that. And then we're going to double check to make sure we got this right. 1, 3, negative 2, negative 1, 0, 1, 0, 5, 0, 0, 1, 2, 0, 0, 0, 3. Yep, there we go. And so we're not going to go ahead and finish that. We're going to leave that to you. But I bet you when we get down to here, you're going to see something very, very similar to this. And I want you to ask yourself, the identity matrix, what's going on with that and where might I use it? But there you go.